Okay, this is the second part of the welding. We're going to work problems 9 through 15 on this one. And so it's asking us to find y and x, and both of those are part of right triangles. Now, on first appearance, I would say, well, y looks like the exact same distance as this height right here on the truss bridge. But what we know is that if you've got a bridge, they're not going to be perfectly suspended. So it should be very close to 37 feet, but it's not going to be exactly 37 feet. So we kind of have to treat these. I'm going to pull this right triangle out so I can look at it a little bit closer. But so we're looking at this one that's y, and we've got 32 feet 6 inches right here, and we've got 48 feet 11 inches right here. Now, the first thing I would do is not deal with this in one unit. I mean, not in 2 units. So I would say let's go ahead and convert this all to inches. So the first thing I'm going to do is take 32 times 12, because there's 12 inches in a foot plus 6 extra inches. I'm going to convert this to inches. So 32 times 12 plus 6 is 390. Okay, I'm going to do the same thing to the top here. I'm going to go 48 times 12 plus 11. That gets me 587. Okay, so now I know that this is really 390 inches, and this is really 587 inches. Now, I can do my whole process of doing my a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse. On this triangle, this would be the right angle, and so the hypotenuse is the one that's directly across from it. So it would actually be my 587 squared. Now, it doesn't really matter whether we let which one of these we let a or b, the other two angles that we have here. I'm going to let 390 be my a, and then I can say that b is this y squared. So I'm going to say, okay, 390 squared plus b squared. And actually, just so that we can keep this consistent, let's go ahead and say that that is our y squared. Okay, so I can solve this problem by subtracting 390 squared on both sides, because my goal is to get this y squared by itself. So you can really do that all together instead of having to calculate it first. So 587 squared minus 390 squared is 192,469. To get rid of the squared, we'd have to take the square root of both sides of our equal sign. Okay, and that's going to leave me with y is equal to the square root of 192,469. Now, it says we're supposed to round our answer to the nearest inch as needed. Okay, and so I'm getting 438.712, and it kind of goes like that. So here's what I know. It says that we're supposed to round this to the nearest inch. So I'm going to go ahead and say we've got 439 inches. But on the answer, it's going to ask you to put how many feet and how many inches that is on both of these. So I'm going to go ahead and do that. So we found what y is pretty much here. So if y is 430, we rounded to 439 inches. Okay, the first thing we'd want to do is divide that by 12, because we know that there's 12 inches in a foot. So 439 divided by 12 gets me 36 and some extra. Okay, so we know that we have 36 feet. I'm going to go ahead and put 439 here for y. We've got, and if you do 36 times 12, okay, 36 times 12 gets you 432. But we need to know the difference between 439 and 432, so we would subtract those, right? 439 minus 432 to get our 7 inches. Okay? Now, let's do the same thing for, I don't know why I wrote inches twice, sorry. Let's do the same thing for x here. So on x, we have a right triangle, and this time the right triangle kind of looks like this. Now, we know that y is on this side. We do know that the height is 51 inches, or 51 feet 2 inches. So we'll have to do some calculations there. And y is 439 inches. We just found that. Okay, so we're looking for x. Let's go ahead and look at what this is. So 51 times 12 plus 2 is going to be 614. So this is 614 inches. Now, this time we know both of the legs. We don't know the hypotenuse. So we would just need to do 439 squared plus 614 squared is equal to our x squared. Okay, so 439 squared plus 614 squared is 569,717. And now we need to get rid of the squared up here, we're going to have to take the square root of both sides. So x is equal to the square root of 569,717. And I'm getting 754.7, and it says to round this to the nearest inch, so 755 inches. Okay, so we know that we've got 755 inches. So what we'll need to do is 755 divided by 12 to get our number of feet. Okay, that comes out to be 62 feet. Okay, then 62 times 12 is 744. Then we're going to need to subtract these two. So 755 minus 744 is 11. So 62 feet 11 inches. Okay, so that's how that one's probably the most difficult or the longest problem on this. Let's look at number 10. It says, what length of 1 inch stock is needed to bend a piece of steel into the shape as shown to the right? Use 3.14. So what we know is, we know that we've got this, obviously we've got 5 inches, and then we've got this, we've got 5 inches from here to here, and then we've got this distance around here that we're going to have to find, and then another 5 inches. So this little section right here is half of a circle, and we call that circumference if we're looking for the distance around the whole circle. So to find the circumference, you would use the formula 2 times pi times r, which is your radius. Now, we don't have the whole circumference. We only have half of a circle, so we could divide this by 2, which is going to make these two cancel out, and we just really have pi times our radius. Well, they're telling us to use 3.14 for pi in this problem, and the radius is 2 inches, so times 2. And if we do that, we're going to have 3.14 times 2, which is 6.28. Now, we want to also, don't forget, so we've got 5 inches, 6.28 plus 5 inches. So we've got to do 5 inches plus 6.28 plus 5 inches and that is going to get us 16.28 inches. And it says the length of 1 inch stock needed is approximately 16.28 inches. It doesn't say what we're supposed to round to, so I'm going to leave that there. If it says what to round to on yours, you're going to want to be a little bit more specific. I just looked at the answer to one of these and it rounded to the tenths place. So I'm going to say probably 16.3 inches is what you would want to go with there. Okay, to determine the ultimate tensile strength of a small diameter pipe, a welder uses the formula UTS is equal to L over A. L is the maximum load of the pipe in pounds, as recorded on tensile the tensile machine, and A is the cross-sectional area of the pipe. If the pipe shown in the figure has a maximum load of 28,490 pounds, find the UTS for the pipe in pounds per square inch. Round to the nearest 10 psi. Okay, so we know this formula. UTS is equal to L over A. Okay, so to find the UTS, well, one thing we do know is we know what L is. They told us the L in this problem is 28,490. Okay, so A is supposed to be the cross-sectional area of the pipe, and so we're looking for this area in the blue part. Okay, so we're going to need to find the area of the bigger circle, the circle on the outside, and we're going to need to subtract off the area of the inner circle. So the area of the bigger circle would be, now to find the area of a circle, you're going to do pi r squared, and they didn't tell us to use 3.14 up here, so I'm going to actually use pi. The radius of the big circle, right, the diameter is 1 all the way across, so the radius would be 0.5 squared. Now the diameter of the smaller circle, the circle in the middle, well, our radius is a little bit different on this circle, so we kind of need to figure out, well, what is this distance from here to here? Well, we're going to have to subtract 1/8 and 1/8, and 1 minus 1/8 minus 1/8 gets you 0.75. Okay, and if we divide 0.75 by 2, which would give us our radius, okay, so from about here to the middle of the circle to here is 0.375, and I got that by dividing 0.75 by 2. So we want to subtract off another pi r squared, but we're talking about this white section in the middle, that smaller circle radius, so we can just get the area of the blue. So we're taking the big circle minus the little circle's area, so that's going to get me 0.375 squared. Okay, and if we do the math on that, I'm actually using the pi button on my calculator instead of the 3.14, because it didn't tell me to use 3.14. Okay, that's getting me a really big number. I'm going to go ahead and write down 0.3436116965, which is what is supposed to get plugged in here for this area. What I would do right now is I would type in 28,490 divided by the answer on my calculator, and I would hit second little negative sign, which would give me the answer. That would give me the exact thing instead of having to round. But you should still, even if you type the second number in, you should come really close to what you should especially since they're saying round to 10 psi. So okay, I'm coming up with 82,913.35, and it just keeps going. Now the answer is round to the nearest 10 psi. So in this example, if we're rounding to the tens place, we would just leave it 82,910. Okay. Find the lateral surface area and the volume of the solid. So the lateral surface area is the area of all the sides on the outside. So when you think about this, we've got these rectangles on the outside of this. I've got this one in the front, and then there's one in the back that's exactly the same size. So those would be 9x4s, and I have 2 of them. Okay, now what about this on the back side, on this side? It looks like it's a 5 by 9, and I've got 2 of those, right? I've got this one in the front, and I would have one in the back. So I've got 2 5 by 9s. Okay. And the definition of lateral surface area means you don't include the front or the back, or the top or the bottom. So that should be it. 9 times 4 times 2. It's going to get me 72 feet squared. 5 times 9 times 2 is going to get me 90 feet squared. And we would want to add those two together. 72 plus 90 would get me 162 feet squared. So the lateral surface area of the solid is 162 feet squared. Now the volume is still length times width times height, and in this case we would do 5 feet times 9 feet times 4 feet to get our volume. And that's going to be 180 feet cubed. When I'm talking about volume, 180 feet cubed. Okay. So, got a couple of problems where you're supposed to kind of analyze some statistics here and read a graph. It says which category represents the largest expenditure. So it says study the school graph and answer the questions that follow. So we've got the school expenditures here, and it looks like the largest category would be our tuition. Okay, which category represents the smallest expenditure? Well, the smallest little section of this pie is the lab fee. And the student spent a total of $2,400, so the combined amount that went towards tools and lab fees was, okay, well, so she spent he or she spent $2,400. And if you look at the lab fees, they account for 7%, and tools account for 27%. So if you take 7% and you add 27% to that, you're going to get 34%. So if you do 2,400, which is the total they spent, times 0.34, so 2,400 times 0.34, you're going to get $816 they spent on tools and lab fees. And it says if a student spent $200 on materials, and the amount spent on books and lab manuals was, so it says that material fee is supposed to be 10%. So we know that, I'm going to come over here, we know that the material fee is equal to 10%. They want to know the amount spent on books and lab manuals. Well, books and lab manuals are supposed to be 19%. So I could cross multiply to figure out this. So 0.10x is equal to 200 times 0.19. So 0.10x is equal to 38. Then we would need to divide by 0.10, which is 380. So $380. If they spent $200 on materials, that's how much they would spend on books and lab manuals. Okay. A table of values showing the number of community colleges in various regions of the country is shown to the right. Draw the related bar graph. Okay, so they're asking us to draw a bar graph out of this. Okay, so on their answers, they've kind of gone up like this. They've started this at 0. They've got a mark for 10, and they've got a mark for 20 up here at the top. So we know about halfway, that's going to be 15, right? 5 and 15. You don't have to get this. This is going to be multiple choice, so on the first bar on A, you're going to want to go up to about 12. So under 15, between 10 and 15, but closer to 10. B says that that one is 16, so a little bit over 15. This one's 12, this one's 16. C, it says that C is 3. So not even up to 5 over here. D is 5. I'm going to go right up to 5. E is 8. We're going to go almost to 10, but not quite. And F is right at 10. And so that's how you would draw your bar graph on that. One's kind of easy. Okay, last problem. The following table shows the average prices per gallon of both regular gasoline and diesel fuel from 2003 through 2012. Construct a double bar graph illustrating these prices. Okay, so we want a double bar graph illustrating these prices. So we're comparing these two things. This one's also going to be multiple choice, and I don't know if I'm going to do this entire thing, but so on this side we would have cost per gallon. Okay, and this is the year. And I'll give you a couple of examples of this because I just don't think it's necessary to do the whole thing. But we've got 03, 04, and we've got, this would be our 0, 1, 2, 3, 4, 5. And so in 2003, you're going to want to have two different shades on the graph. So I'll use blue first. In 03, it looks like the cost of regular gasoline is $1.29. So we would go up to about $1.29, and we would that would be shaded in one color, and we would note that that one color is regular gas. Okay, and then we would want to make sure that we have another color that is our diesel gas. So we would go up just a tad bit higher because it's only 1 cent more, $1.29 for, no, it's lower, sorry. Diesel gas on this one is lower. So it's a little tiny bit lower at $1.28, and we would want to shade that in. Okay, when we go to 04, go back to my blue. Okay, it says that regular gas is $1.97, so I would go up to almost 2, shade that in, and then we would have our diesel gas, which it's 222 in 04, so a little bit higher than $2, and we would shade that in. So you're going to compare, it's multiple choice, you'll want to compare which graph is the correct one, but you're going to just read the chart and see that it graphs all of those correctly. Okay, so that's it on the welding chapter 8 through 12. Feel free to print off the study guide, work it through, and use it for notes while you're doing your test.